For our final ME30 project, we were tasked with creating a car that could pick up some kind of object, detect its weight, and place it on a balancing beam to make sure it didn't tip over. My group created a car that had two motors driving its two front wheels, as well as one motor that spun a 1:16 gear ratioed gear train. As can be seen in this clip, the car can lift the weight pretty easily as it's quite torqued up, and we are moving the weight towards the appropriate part of the balancing beam so that it doesn't tip over when the other robot places a weight on the other side. The biggest challenge with this project was ensuring that we were able to pick up a weight like 1 kilogram at a distance because the motors we were given weren't the strongest, so we had to ensure that we had enough mechanical advantage with our gear train to be able to lift it, and also so that all of the subsystems in that gear train were really tight so that we'd see no slipping. All of this was controlled by a Raspberry Pi, which sent signals to two motor drivers to control the motors, as well as a KB2040 to control or to figure out what the load was through our load cell and op amp. We were told that the heaviest weight would be 1 kilogram, and we designed our system for that. But in the end, we were curious about how much our gear train could lift. So we just tried adding some weight and seeing what happened, and it turns out that we can lift almost 2.5 kilograms. Overall, this project was a great way to get some experience using Raspberry Pis, as well as figuring out how you can really get mechanical advantage into your systems. So a special shout out to my teammates, Aiden and Matthew, and thank you all for watching.